Hello, hello. Good evening, everybody, and welcome to Spindle TV. I'm your host, Laney Shaughnessy. Thanks for joining me tonight. How's everybody doing this evening? Hopefully, you're all doing well. Got a little sawdust on my shoulder. Let's see here. Looks like a lot of you popped in. Roger, it does have a starting time. It's right now. I'm just looking at some of the comments everybody is going in here. Tonight we are talking about fourth axis. Now, before I get into tonight's project, I wanted to talk to you about last week's project, the dovetail box. Thought I would show off the dovetail box. Let's see here. This was the minus the dust. I just went with simple hinges and stuff and everything. The inlay, I had a issue with the inlay. The first inlay that I did, I got lazy after that class, and I didn't put any clamping pressure on it. I just put a brick, a couple of blocks. I have some blocks I just set on top, and I put some blocks on top and didn't get enough clamping pressure. So the inlay wasn't actually seated down into its female pocket. And when I went to clean it up, it all went away. With this one, I had a bit of an issue right on these thin areas right here and here. If I were to go back and do it again a third time, and basically the second time, all I did is I put the lid back on the table, rerouted out the grooves, and then redid the male inlay. But if I were to do this again, VCarve inlay again, I would make these lines here a little bit thicker so that they went a little deeper, because on these thin areas here, if I can kind of get my camera going right, where's my camera at? These areas in here and stuff, when I sanded everything, I sanded most of that line away. That line should continue on. Where's my camera at? That line should continue on up through here. And I started to sand it away here, and I did sand it away over here. And this one I almost sanded away. So I'd make those lines a little bit thicker on the inlay, but all in all, it turned out okay for what it is. It's just a simple box. Um, the inside is unfinished right now because I'm going to be flocking it, flocking it. So it's just unfinished. There's no finishing done on the inside yet. And all on there, I'm going to flock it and put a kind of almost like a felt throughout the whole inside of that with flocking. I got to order some flocking in from Rockler or something. But so yeah, so that's the dovetail box. As far as anything else, let me see if I can get it back in here. I'm happy with the dovetails, the joinery, and everything. Um, but uh, for just what it is, it's just a simple box. I didn't make it for any particular reason or anything like that. I just made it for the class. So I'm sure it'll have a purpose. It'll store something in there when I put the flocking in there and finish or what have you. I call it a jewelry box, but I'm not gonna put I don't wear jewelry, so I'm not gonna put a jewelry in there. I'll put something in there. uh, yeah, tonight we're fourth. Uh, Mark did need a haircut. Definitely do need a haircut. Hopefully one day we'll be able to go to again or whatever you want to call them. We're gonna do axis tonight. I'm gonna fourth act approach a rotary job. Let's not call it fourth axis. We'll call it rotary because it could be somebody's fifth axis. Who knows? But a rotary job, and I'm gonna talk about rotary inside VCarve Pro as well as Aspire. Now the project, cutting a rotary job, this monster piece right here. I do not know what this is. I want to say it's something. I don't know. I have a forester customer who's a forester, and he sends me all kinds of unique blocks of wood and different things, and let the well, camera lighting catch up. So uh, this big boy right here is 6 inches by 6 inches. And it's about 4 3/4 inches wide, and it's that we're actually going to be carving it between centers, so it'll be rotating this way. And so we're going to make a rotary project out of this block of wood on the digital wood carver fourth axis, but in general. So we're going to talk about fourth axis rotary, how to set that up. And hello, Dave Gatton. Hello, Crystal. Hello, Big Daddy Fish. Troy, Mark, Jim, Paul, everybody. How y'all doing tonight? Hope y'all are doing well. But yeah, we're gonna carve this big old chunk of wood right here. Right now it's 6 1/8 by 6 1/8. I gotta trim it down to 6 by 6. 4 3/4 inches in its length because I'm gonna be running it on the length. So between centers. And like I said, it's gonna be rotating this way. So we're gonna make kind of like a vessel vase. And Dave will remember this in one of our conversations online. Dave Gatton, one of his guys, like I think it was Javier said, uh, that single rail sweep that asked me that answered that, that's a question I want to ask, about weaving and things like that. So we're gonna do like almost kind of like a little basket type weave on this project as well. So you'll get to see how that layout goes. All right. So hopefully you're as excited as let me say that without laughing. Hopefully you're as excited as I am about this upcoming project. And let's see what we can do here. Okay. All right. With that being said, let me share my screen. And of course, I didn't set up my screen resolution. So we'll jump in there and do that real quick before I do share my screen. Let's see here. So that way it makes it all nice and big for you guys and girls. Um, and it really makes my screen jump out at you. All right, all right, all right. All right, we're going to start off in the VCarve Pro as an example. And we're going to show how one a rotary job in VCarve Pro. Then we're going to actually transition into the Aspire to actually make the project for this because there is some modeling tools involved, some modeling involved in stuff. Oh, I got the hiccups and I don't know why. Why did they start on me? All right, so let's go ahead and click hide here. So for this project here, of course, we're going to click rotary and let's get maximized up there. We're going to click rotary we're going to do a rotary job. And on the rotary job, we're going to go with a 15-inch length, and I'm just going to make a small project. I cut a piece of uh, walnut 2 inches by 2 inches by 15. So we'll go 15, and on the diameter, it's actually the diameter is my blank is 2 inches by 2 inches. But if I were to, let me jump out of this for a second and let me see if I can illustrate this a little bit better because this is important. But if I were to draw a 2 by 2, 2 by 2 block here, and if I were to true up a cylinder out of this 2 by 2, if I were to say that my diameter was 2 inches by 2 inches, well, what I would end up with is a flat here, 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 and here. When it's truing up and rounding this up, I'm going to end up with 4 flats. It's not going to be a true round. So I'm actually my finished diameter when the corners get knocked off and this thing gets rounded up, the finished diameter is actually going to be 1 7/8, so 1.875. Um, and what that's going to do is it's going to allow it to mill material off all 4 sides and give me a true round cylinder. All right. All right. So if you have a blank, 4 by 4, 6 by 6, whatever, expect that you're going to be coming in roughly a 16th on each side or so to get a true round. Otherwise, you may end up with flat spots on all four sides because our stock is square and flat. All right. So, with that being said, if I go back to the job setup here, my job setup is actually going to be 1.875. Okay. Okay. All right. Y'all with me on that one so far? All right. Now, for us, with the digital wood carver, we Z0 out of the center of the cylinder axis. So think about this flat object here. When I wrap it up, the bottom of the material becomes the center. So it's almost like working off the bottom of the material if you were in a flat orientation, but we work from the center. Now you could work from the cylinder surface and everything. I find it a little bit more accurate and everything to work off the cylinder axis, and so that's the method I'm going to teach. But man, experiment, have some fun, play around with it, and see what the different results you get. But I, in the last, I would say, going on 6 years now, I've never worked off the cylinder surface because, and I've trained to work off the cylinder axis, and so I'm going to continue that methodology tonight. Now, with the XY datum, we always zero out on the front edge of our cylinder stock or our stock. So it's the bottom left corner. And the setup of this, that bottom left corner, um, if I can one more time, let's get out of this for a second. And let me draw my 1.875 by 1.875. Gonna be square for right now. Bear with me. Hang tight, and you'll see where I'm getting at. Um, if I were to take and unwrap this into this flat drawing area here, that piece would be split right on the one of the faces. It would be split right in the center, and the part would be unwrapped in a fashion that, let me see if I can kind of illustrate this. You go there, stop. You go here, and let's grab these guys. Let's move them down here. Pretend along with me. Let's grab this guy and wrap him up here. All right, so when it tends to unwrap that cylinder into a flat plane, it's basically taking it from the side of that block. So let's get that back together here. So on our digital wood carver units, now for most of you, you have a your fourth axis may be on the table, mounted on the table, and you have your router kind of overhead. Let me see if I can draw a router here to simulate this. Now I'm going to select all these and center them up. Then I'm going to hit G on my keyboard. After I close this tool, I'm going to hit G on my keyboard to group those together. So let's pretend this is our router. And so when you center your router over your stock, you're centering it over the center of your piece, and the router stays at that orientation, and it just travels back and forth, as the fourth axis part rotates, depending on what needs to be done. Well, similarly, with the digital wood carver, our unit is mounted off to the side. So our A axis, which is the router up and down when you're in fourth axis mode, we would center that bit onto the center of our stock, our flat. And that's a representation of this lower left hand corner. Because if I were to wrap this up into a cube, this seam and this seam up here would meet in the middle here. Okay. And so that's our A axis. So when we Y0, right? Y0, whether you're, now keep this in mind, whether you are off to the side like the digital wood carver, or your overhead, your Y0 is the flat face facing the router bit. Okay, it's not a corner or anything like that, the flat face. And the same thing for the digital wall carver folks. That flat face facing the bit, nice and parallel, or what do you want to call it, perpendicular to the table, 90 degrees to the table, the unit table. That is Y0. Okay. Y0. And then X0 is at the leading end of your stop. All right. You guys and girls with me on that so far? You good? All right. Now, when we want to, let's get back to our job setup here. So we want to zero off on the bottom left corner. Okay. So that means all the way towards the head end of our material and at the center of that block or round part or whatever you got. Now, for the orientation, we wrap on the digital wood carver, we wrap our y-axis along our x, and most others, I believe Dave Gatton does as well. His router is overhead. He changes his y-axis from the router moving side to side to the rotary, and so therefore he wraps the y value around the x. Same thing we do it with our digital wood carvers and all. And everything. So this is the option to use. Now, some machines where the um, fourth axis might go along the y-axis, and their y-axis travels back and forth along the cylinder, and their x is what turns the cylinder. Then they would wrap along, the x values along the um, y-axis. So 90% of the time you're wrapping along the x-axis, and whether you're a digital wood carver owner or not. All right. So that's our job setup. So we've got our cylinder length, the diameter, cylinder axis, bottom left corner, and along x-axis. All right. We click OK, and that would set up our job. All right. All right. You guys and girls, y'all are following along pretty good tonight. All right. So now that we have our material set up, now we got to figure out what we want to do. Now, what we're doing basically is considered in a sense, a wrap job. We are wrapping the Y values around that X axis. So we're wrapping it around. So whether we were V carving something in our cylinder, let's say I was saying hello world. And let's take that, let's weld that because we got overlapping lines, right? We don't want that. So we're going to weld that together and replace it with our nice welded text. But if I were carving this, let's do a VCarve toolpath, 0 flat depth, 60-degree V-bit. Very simply calculate it. If I were to, let's unwrap this so it looks like our flat plane here for a second. If I were to carve this, okay, if I wrap this cylinder up, then it's wrapping that Y value up and down, along, and that's hard to make the mouse go around this white block, but imagine that it's going around this white block. We would wrap it around that X axis. All right, let my mouse stop there. Let that regenerate. Catch up to me, Vectric, so we can just move along nice and smooth. Now, the same goes for if I had this turned 90 degrees, and I'm going to undo that, and I'm going to go Control C, Control V to make a copy, and then I'm going to rotate that 90 degrees so that I can size it, down. And let's say that I was having it wrap around the cylinder, and if I were to V-carve that, calculate. Oh, I had an end mill in there. It shouldn't have been in there. If I were to wrap that around, so in our flat plane, it wraps around. Let this regenerate. Catch up to me, Vectric. You can do it. Every time you move a wrap job, it takes a second for it to regenerate. But now, as I rotate, I'll use these two icons up here. As I rotate the part, that hello world is getting wrapped around the cylinder. Okay. So if I were to unwrap this, it looks like that, but it's wrapping around. Right. So when we're doing, cool things like, which I'm not doing tonight, we might do a project on this, but somebody had asked a long time ago about making a kind of a design relief cookie cutter, for like a rolling pin for in the kitchen, rolling pin, that has little designs on it. And when you roll it over dough, it cuts out those designs and stuff, like a little cookie cutter. And I've made holiday ones in the past and everything, and we might do a project like that one day if we when we circle back around the fourth axis and all. But we're not doing that tonight. Um, the whatever design or whatever, process we're doing, whatever we carve is gonna get wrapped around that cylinder. Now, same thing with models, okay? Let's say that, I had a cylinder here and I wanted to just from my clip art, gallery, let's say that I wanted to oh, I don't know, let's see what we've got in our clip art gallery as soon as Vectric catches up with me. Let's say we throw the duck on here, the flying duck. Yes. All right, if we were to look at this in the 3D view, all right, we got our flying duck there. But if we wrap this guy up, all right, let's turn him around. I should use the rotate button, it'd be much simpler. But that duck, let it regenerate. Regenerate for me there, duck, duck, goose. It takes a second for it to all the pixels to catch up to regenerate. There we go. It'd be wrapping that duck around that fourth axis. So it's wrapping it around that fourth axis. So we could make all kinds of cool stuff, little totem poles or whatever the case may be. They don't have to necessarily be little, but um, we would do that and everything. So whether we're working with a model that's going to be carved around our cylinder, you got to make sure, the model's got height to it, right? So you got to make sure your cylinder thickness can accommodate the height of that model, or else you end up with little pencil stick thin. Um, Here, I'll give you an example. Let's say that my material setup here was not 0.1875. Let's say it was 1 inch, right, in diameter and everything. And click OK on that and let it regenerate. Let's say that I wrap that boy around. I'm going to have a little hole pencil. Let's close out of this and turn off this. I'd have a little low pencil thick, 1 inch diameter because I had, part of that 1 inch is my model, not just the diameter of the cylinder in the middle, but the dowel, if you want to call it now, but the model too. So from the highest point of the model to the center is going to be half that diameter. So you got to, make sure your stock is big enough because, man, that just I don't know, unless you're a Harry Potter wand or something and you're part of the Goose Brigade or something. I don't know what this would be for. It wouldn't be for anything. But the so you want to make sure that your stock diameter can accommodate the model, right? And now I'm going to be bringing in. Let's get back to our job setup here, and let's change this back to the 1.875. And I'm going to actually be bringing in a third party model file into the VCarve Pro. Now, VCarve Pro, I can't create a model from scratch, but I can import models from the clip art. I can import models from the clip art gallery. I can import third party model file, one third party model file into my project, and that's what I want to do. Is I want to import a model into here, and so let's go over and do that. So we're going to go into the modeling tab. We're going to go import model or 3D component. And I'm going to grab this one 3D object here. Let it import it in. Now, when you import a 3D model into the software, it is, I don't know if you can see that little, what looks like a little red speck right here that my mouse is circling around. Well, that's my material. This is the model. Model, that little speck is my material, right? Well, if we look at our model here, one, we're going to be bringing in the full 3D model. Okay. All right. And now, if we look at this blue outline here, this is basically outlining a cylinder, like this model inside of a cylinder. However, that little red speck right there in the middle of the cylinder, that's my project piece, right? So I need to, first of all, initially orientate the model, because this particular model, if I were to kind of, be looking at it here, it might have come into the software facing this way. It could be facing this way, right? So like it's like, I got this big old wheel of a cylinder that I'm going to be carving this leg sideways out of, which would not do. It could come in. It all depends on how the creator created it, right? And now in this case, the top is the proper orientation. That length, that side to side across that, 15 inches length. But if we look here, the model's diameter is 339.9275 by 1255 on the length. Now, this model was created in metric, but we are working in inches. So that's 1255 inches by 339 inches. What we need to do is we need to convert or change that size. So we need to scale the model to fit our material, or we need to type in a more appropriate size, right? So I'm going to scale the model to fit the material. But before I do, I want to kind of come look at this at an end view here. And I tell you what, let's scale it first and then we'll talk about this stuff here. So let's scale to fit the material. So we'll click that button and bring it down. So here's our material. Now, my material is 15 inches overall length, but the model, based on that 1.875 diameter, when it's scaled to fit within that 1.875 diameter, that 1 and 7/8 inch diameter, it scaled the length of the model appropriate for that. So if I wanted a full 15-inch leg, I'm going to have to jack up the diameter, of my stock. There's no ifs, ands, or buts about it. I'm just gonna have to do it. I could probably stretch this out. So let's see here. Model length. If I said 15 inches, right? Let it regenerate that. And it's keeping the aspect ratio. So as I zoom that in, now I need at least a 4.5 inch diameter piece of stock, 4 1/4 is fine too. But I need that to fit this model and all. If I would have reset the original size and then scale to fit the model, so it scales it appropriately down. If I would have said, okay, let's unlock the aspect ratio and make this 15 inches, well, that's gonna this table leg is gonna get distorted to accommodate for that, and that distortion may not be appropriate for what we want. Okay. So, very important that you kind of gauge what you're carving based on the size of the material. All right. So let's reset that size, original, get it back to its original size, and then scale to fit the model. And then what I'm going to do, since I am working with a 2x2 here, I'm actually going to resize my material block. So I'm going to check off that box to resize my material block for that piece of material. When I click OK, it'll do that automatically. But before we get into that, I wanted to talk about these interactive rotations and things. Now, if I come down the x-axis, like we're looking down the length, we have this kind of bullseye. Let me see if I can zoom into that. right at the center. It's showing our cylinder center here. And sometimes, whether it's this end or let me flip this around to the other end, come on around to the other end there, dude. Spin around there. We may need to adjust center, on our cylinder because that center axis, there's a red. There's a virtual red bar running through here, and let's get back into a Z orientation, kind of looking down here. And if I adjust this, if I rotate this interactively, and so I'll go interactive along the y. Let's see here, along the Z axis. Okay. Um, I could pivot this part, right? So here's that virtual red center, right? That's our center of our cylinder right there. Well, sometimes parts come in funky. So it's up to us to make sure that we get them, centered appropriately and everything. And this wouldn't be centered appropriately, right? So we need to interactively. So Z is kind of this up and down pivot. So, I'm just kind of pivoting it within this cylinder of the stock. Y, a Y rotation allows me to kind of swing this thing around almost I'm kind of going diagonal right now because I'm not in an orientation. And then X is a rotation. Okay. So let's get back to our Z orientation here. And let's basically get back to our original size. Get back into a top view for a second. I'm bringing it back to its original state. And scale to fit the material. Let's talk about this Z. So let's say that my model was not quite centered. Well, it's up to me to appropriately. I'm just dragging my mouse up. I went too far. I overshot it. But I want to try to, do my best to center the piece. Now I can change my angle. So if I look at it from the X axis here, now as I'm moving that Z, my mouse up and down, I'm pivoting that piece on its center axis here. So let's see if I can. Oh, I'm sorry, I'm going the wrong direction. Left and right. So it's my goal to get that center virtual line running down the center. So I want to move this to the right, left and right. I don't know why I was going up and down a minute ago, but I want to get that the best I can to center. Okay. And so now I need on the Y, or I'm sorry, on the X, get back to there. On the X, I might need to rotate the part. So the X is rotating. So if I move my mouse, are you gonna turn for me there, dude, so I can show them? If I move my mouse to kind of that left or right orientation, now I'm kind of rotating the part inside that center and everything. Now, if I were to get out of interactive, I go back to view here. If I were to rotate this around, what my goal is, last time I'll say this, is to make sure that I'm centered. Now, if you see that red, let me see if I can zoom into that. You see that red right here? That's my cylinder center, right? So I'm not appropriate because when this thing mills away, it's remember, I got a live center in each edge. So when this mills away, there we're going to be a little shy on this end. So what I need to do is let's get this, and it's kind of weird how we have to orientate this. But I need to come in on my Z axis again, Z axis rotation, look at it down the X axis. I want to rotate it 180 degrees around, so I got to actually do that manually. Oh, Lord have mercy. I was in the see what happens when you're interactive, it's rotating on that. I wanted to rotate the view around, not the actual Z. So let's get this Let's get this appropriately set back up here. So I'm very pretty much centered there, but now I need to bring it down to the center here. So on my Y, oops, little overshot a little bit, right about there. Stop. All right. And so I've got my two ends centered. Oh, dadgummit, I just don't move. You gotta don't click your mouse in the screen if you're still in the interactive stage. So let me get this back up where he belongs. All right, now get out of that interactive state there. Um, and you know, fairly centered on that end. Let's look how we're doing on the other end. Pretty good there as far as the center goes. And right, if we go in here, we see a little bit of our red rod. That's because this leg curves inward, and there's nothing we can do about that. Okay, it's just there's nothing we can do. So we're going to resize the material block. Let's get back into a Z orientation. We got it orientated properly. And we're going to go ahead and click OK. And that's going to bring our model in. Now, what's going to happen is when it brings it in, because I'm resizing the material block, it's going to resize. Your component will not import accurately because the model plane of your Z is not set to the center. Would you like to correct this automatically before continuing? Yes, I would. Set it for me on the center and click no because I have toolpaths in there. And that's an unwrapped view. Let's wrap this bad boy up here for a second. But the software realized that I wasn't quite centered on my axis. So it said, hey, you want us to do it automatically for you? Get you squared away? I'm like, sure, why not do that? All right. So it did. It brought it in and it centered it for me and everything on that new size. Now, so this is our table leg. And, imagine that rod running right through the middle here, right at this dip here. Part of that rod is going to be coming through to the center here because this end here is offset from this one. So if I come into kind of a Z view straight up and down, and if I were to rotate this to its side a little bit more, you can see that my center line here and the center here is off center. It's off. So you would see part of that red coming through and everything, and that's appropriate. So center to center. So you just gotta. It's all about the orientation when you're bringing the models in and everything. Now, this is a wrapped view. Let's unwrap the view and look at what it looks like in a flat view that we're kind of creating the toolpath. Here's our 2D view, a little grayscale image, right? 3D view, it's our flat plane. All right. Now, you see the tan area back here. Okay. That is the void. There's a void, there's a hole there and everything because that area when it's wrapped up, the meat here, let's unwrap it real quick. The meat here and here, that's the back side of the cylinder. Remember what I said about, let's get this into a Z orientation. Remember what I said about this edge and this edge, when it wraps around, that's the seam. It seams together in the back end. So right now on the front side, we're seeing through this and everything because it's hollow. Remember, like I said, our red shaft was showing. So it's all hollow up here. But on the back side, when this is wrapped, there's a seam on this. And if we turn this, I'll show you where the seam is. So let's come back here. That's the front. Let's go all the way around, all the way around, all the way around. See if my seam's on. I think it's on the other side, and I just zipped right past it here. Bear with me a second. It is, because I'm a goofball. Let's get back around there. There we go. Barely see it, but there's our seam. That's where our two ends come together to form this seam right down the middle. And you can see a little bit of it right about here and everything. And and also it's all about how you orientate the model. Now, very simple enough. Whether I'm doing a 3D model like this, or I'm taking a piece of clip art and wrapping it around my cylinder, or I'm taking some carving and I'm engraving on a pin, or whatever the case may be, V carving and stuff. It's all wrapping. We are wrapping these models in a 360-degree orientation. We draw in a flat orientation here, but we're wrapping that Y value. Remember, up and down is Y. We're wrapping it around that X. When it wraps around, it creates that cylinder. All right. Now, if I were 3D carving, or if I was carving this 3D model, then once I have everything laid out and positioned and all, and it's ready to go, and it looks good in the flat view, nothing, I don't want to carve any V carving over here. I could carve some text and something on the back of this leg if I wanted to, whatever the case may be. I'm ready to start creating some, you know, tool paths. Now, in the tool paths, and let me delete these three so we don't get confused and those hello world toolpaths I made earlier. When we're working with a 3D model, just like if it was a flat board, 3D rough, 3D finish. Okay, we have our two toolpaths. If I had a 2D toolpath, such as a V-carve of a graphic image that I was wrapping on a cylinder or something, then it's very important if I have a 3D model here, if I was carving hello world on these flat areas or anywhere on this model, it's very important that when I calculate this toolpath, this 2D toolpath, that I project the toolpath onto the 3D model. It's very important that I check that before I click calculate, because we need it to flow with the model. We need that carving to flow with the curves and all that good stuff. There's nothing really scientific about fourth axis. It's all in the setup, how to zero out your machine in the fourth axis and everything, and then bring it in. Where it gets fun is when we actually have the ability to create models from scratch and things like that. So a lot of people that have that fourth axis and want that ability, and I make table legs. I go on eBay, Etsy, Turbo Squid. There's all kinds of places that I can go and get 3D models of table legs. eBay is a great place to find models and all of table legs of different unique table legs and balusters and all kinds of things. That's where this model happened to come from. And I can bring these models in, calculate the toolpaths, carve them all day long. But sometimes, just sometimes, we want to be able to create our own unique model. Now, I could do something similar to this. I could not do the contour and the curve and everything. That's modeling. That requires Aspire. But in a 2D environment, if I were to come in here and turn that off, if I get to my blank here, I could come in and I could build off of this blank with some 3D work. Let's grab our clip art here. Of course, it's going to be the last one. And let's go into our decorative. Here we go. And on our decorative, let's go ahead and let's grab this guy, or not him, this guy right here. And I'm going to hit the number 9 on my keyboard, or 0 on my keyboard twice. And we'll, one more time. There we go. And let's size him a little bit more appropriately. And of course, I hit rotate. Grab the right triangle or the right blocks there, the white blocks size. Okay, let's get that sized about like that. And let's get this pulled up here. And then I'm going to go into my drawing tools and align up and down, center, get it centered. All right, so from there, let's split our view so we can see what's happening here. Okay, from there, let's go into our clip art and let's see what else we've got here. Let's say that we want to throw this in there. And let's hit the number 9 key twice. Excuse me. Go back to our drawing tab and align that to center. All right, cool beans. Now I want these two models to interact. Okay, I want them to merge. So they're merging with one another, right? Just like they are. If I were to click in here, it merges with that. All right, let's go into our clip art. Let's see what else we got here. Ba-dum-bum-bum. Let's grab this bad boy. You can drag them into 2D or 3D view. All right, let's go ahead and number 9 on the keyboard. Let's rotate him. Actually, want to keep going all the way around. I want the small end at the bottom. So you're going to hear these dinging because it's the model's got to catch up to itself before you can rotate. So let's get that one more time. There we go. And let's size this model down appropriately. I'm actually going to take this model here and I'm actually going to squish it a little bit. So we're going to squish that in. I'm going to grab this flourish, pull him up, get him in there. And this guy, let's squish him in a little bit because I'm only got a 15-inch piece. And, I'm just using this as an example. All righty, Aphrodite. Now, let's maximize this. And so let's say that I wrap this up, right? Nothing there, right? It's all it's all squished. It's like, well, wait a minute, what in the heck happened there? Well, you can't just throw models on a flat plane that has no thickness to it. We need our stock underneath, and that's a zero plane. So in our modeling toolpath here, we have a zero plane here, so it has no height to it, but we need to add some height to it. So in our zero plane, we need to give that diameter, that meat. So currently, right now, as it stands, my 3 flourishes, my zero plane has no base height to it right now. So if I look at my overall model height, right? My overall model height, let's maximize this out. You see how it's all skinny? That's why it wrapped up. So I'm going to pull this up and pull this out. I want the model on the outside of my zero plane. This, I want it on the top of it, if you will. I want it wrapping around that zero plane. This zero plane is going to wrap around like a toilet paper roll, right? It's going to be a hollow round roll, right? Now it's going to be filled with wood on your actual blank, but that zero plane is going to wrap around like a toilet paper roll. And we need our model that we just built, this light tan area here. We need it on the outside of that toilet paper roll, right? We need it on the top. So that way, with there no zero plane at all, when we wrap this up now, okay, it's going to wrap around that appropriately sized cylinder. Let's get this in the middle of the screen. Work with me there. Come on over here. Come on. Come on. All right, let's drag it over. All right, so we need that model to wrap around, that cylinder and everything. And so right now, my current model thickness, not my Z plane, but my model thickness, okay, is 0.236. That's these guys here, all these models I just dropped in there. The highest, from the bottom to the highest part is 0.236. Now with the Z plane and everything, that toilet paper roll, not counting the hollow center, it's 0.6987 for a total of 0.18693. So it kind of built up the diameter that I'm going to need for this model. But you know what? My stock is 1.875. So I got to change it. I got to come in here and go, all right, so 1.8693, this number here, minus 0.236. No, I'm sorry. Minus 1.875 equals 0057, right? So that's what I need to subtract from the 236. So 0.236 minus, that negative sign helps out with the minus, 0.0057 equals 0.203, and I can resize my model now. Click apply and click OK. Give it a second. Okay, let it regenerate. And so now my, let's get this resized. Come on, boys and girls. 1.875. Get it on there. Let it take a second. You gonna regenerate for me? Here it comes, racing across the bottom. One more time. One more time. It's updating all the model and everything. There we go. All right, so we have to make that change, that appropriate change in everything, so that our part fits within our material. And it wasn't counting that zero plane. It wasn't counting that flat toilet paper roll, that hollow middle in the middle. It was counting the model thickness, right? The model thickness and everything. So I needed to adjust my model thickness so that when it gets wrapped around my cylinder, everything together fits within that 1.875. God, I hope I'm not losing you guys on this one. All right, let's click OK. And let's get back into full view here and unwrap this bad boy. So now we've got our appropriately sized, model, and I could build any kind of model that I wanted to create some kind of unique spindle or table leg or whatever. Um, uh, Whatever rotary axis and everything. And so, this would all wrap around and it would look probably pretty cool, you know? Um, and the thing of it is I, in here, I can't build the model in a way that, would allow me to remove some material. And I can't remove material like I can in Aspire. Aspire, I'd be able to draw a vector around these models and say, remove everything that is outside of that model. And it would remove all this model material of my cylinder here. And it would give me the opportunity to kind of form and build something like that corbel leg that we saw at first. So if I turn this cylinder off for a second, turn all that off. Come on, boys and girls, one more time. You two. And, you know, turn the zero plane off. Don't need a zero plane when we have a table leg and all. And now on this guy right here, right? It's like, man, he got fat, just eating his cake, right? So we got to go into our setup, our material setup, because we made a change. And we need to get everything back to size, right? So we'll click OK and we just got to regenerate. All right. So turn things on, turn things off. It all depends on what you're adding or not adding. And so, these negative sides here, you know, where we're below our center line and all that material would have to be removed. And I just don't have the ability to kind of sculpt and do that in the VCarve Pro. But man, I don't really need that ability. There's so many different models that I can bring in and work with and all, I mean, the sky's the limit. But for those of you that have desktop and pro, you can do everything that I've been doing here, desktop and pro. Bring in models, you can V-carve, you can create little patterns for those cookie cutters and things like that and all. But if you want the ability to aside from dropping in models and creating your own cylinder, if you wanted the ability to kind of sculpt your own leg or profile, that would be an Aspire thing. And I'm not saying run out and buy Aspire tomorrow or anything like that. I'm just saying you got to understand there's limitations, okay, on what you can and cannot do. And so let's say that we were doing a cookie cutter pattern, right? Let's come in here, turn off all the models, get back to our blank board, front and center there, young man. Um, and let's get back into our drawing tab, close our alignment tool. And let's say that, let's say I was doing a bunch of Christmas stars, right? Oh, all right, Christmas stars. So 35, 35. That star looks good to me. All right, let's get a little bit of an array going here. So I'm going to drag this down right about there. And I'm going to use my array tool. And I want, let's go 6 columns. Let's go 12 rows with a gap between point to point and point to point. Let's go with a 3/8 inch, 0.375 inch gap. We don't want to waste too much dough, right? But let's click copy and see what we got there. So that looks kind of, not cookie cutter-ish, right? Of course it would make a bunch of stars and all, but I'd like to make some cool little patterns, where like maybe one cookie, whatever we cut out, would have like half a star in it. Who knows? But we can displace our rows a little bit. So I want to displace every other row. I'm going to displace it by 3/16 of an inch. And of course, let's Control Z. Always Control Z to get back to your original star. There we go. So now when I displace it, and that wasn't a far enough displacement. Hold on a second. Let's go. I should just measure my star, but close enough. All right. So now I've got my pattern here, but these exceeded the 12 rows exceeded that. So we'll go ahead and get rid of that. And then what I'm going to do is I'm going to take this bad boy and I'm going to center it onto my material. Okay. And then if I want the stars to be pockets where it kind of has the little stars raised in the dough or what have you, then I would just simply, V-carve these with with a flat depth. If I wanted to cut out the stars, if you will, then I would need to do a reverse of this by putting a boundary around it. So we'll do a little bit of both. So if I were to V-carve this, let's just do the stars first. V-carve, flat depth. I don't want a very flat, deep depth because of the simple fact that I don't want dough stuck up in my rolling pin that I got to pick out of all the stars and points, right? So we want, very shallow kind of depth, enough to make that impression, whatever it might be. Um, unless I'm doing a big cookie cutter where when I roll it, it actually cuts out that silhouette. And, then I peel it out and throw it on the cookie pan and done. Well, I'm just making a pattern, right? I might be doing a pie crust or something, and I want the whole top of my crust to be stars. I don't know. Use your imagination. I would most likely not use a clearance tool on this. I'll just let the V bit do it. And it's all about time's sake and stuff. With this carving only 3/16 of an inch, it shouldn't take too long. Um, or I could do a bit change, either one. And so, we have this pattern here and everything. And when we wrap it up, we created this kind of rolling pin, let it regenerate, that has this negative impression, right? So when I'm rolling on the star, it's going to kind of push down the dough and have these little stars sticking up, right? Kind of thing, and all. Um, if I wanted to make an impression in them, then I would do it backwards. I would have that VCarve toolpath, have the rectangular selected, rectangle as well selected. And on this one, I'd probably would use an end mill as a clearance tool. And let's give it a little clearance tool. I'll go an eighth of an inch diameter bit end mill. And I would, calculate that. And if I reset this preview, let's unwrap this for a second and preview the visible toolpath. That's going to go around and, carve all these stars and where they're raised up. And think of, raviolis and things like that. There's all kinds of little patterns and stuff that you can find online and stuff that you can use. But now, I didn't offset my rectangle. I didn't bring it all the way to the edge. So I have these little lips here, and that's no good because those lips will show up in um, my cutter. So I need to I need to offset this outward a small amount. I'll go a 16th of an inch outward, delete the original, and then I'm going to recalculate that toolpath one more time because I need that bit to clean up those edges for me. And so that way when I wrap this bad boy up, you know, it's there. And now when I'm rolling this, it's making this indentation impression and things, and all of these stars and all that stuff. So there's all kinds of cool patterns. I think even if we, let's see here, if I open up a tab, let's see how, let's see how, let's see how good Google is to us. If I were to type in, let's see here, Chris, learn how to spell Christmas. Cookie butter patterns. This is an example. It doesn't have to be Christmassy. Um, Pattern. Let's learn how to spell pattern. And I'm gonna get rid of the S and put in the word vector. Keyword search. Filter all that stuff out. And if we were to pop over to the, and I'll probably do rolling pin patterns. Let's see what it shows us. Yeah, let's do Christmas rolling in pattern vector. Gotta love it when it shows you Christmas rolling pins, but not the pattern. See these little patterns and all? There's all kinds of cool stuff that you can do, and everything. These little checker right here. Let's look at this one. Somebody selling their rolling pins. Gonna give this guy or girl some publicity for a second here. Let's see how nice their rolling pins are. Embossed rolling pins is what they're called. Basically, you see they got little fleur de lis, they got little patterns, little flourishes, little diamonds, little hearts. Oh, the little heart one's cute. But literally, that's all we're doing, right? That's it. Now, as far as the handle, to be able to sculpt that kind of handle and everything, that would require a little bit of modeling, which requires Aspire. But what I normally do with the rolling pins is after I carve them, and they're small, they're short, I bore the holes, and you can buy handles, rolling pin handles online. Put a threaded rod through there, or steel rod and epoxy the handles on so it rolls in between the handles. But you could take your cylinder, have some extra waste on there. If you have a lathe, you could take it from carve your pattern, take it over to the lathe, and finish up with creating the round handles. If you have a spire, you can just draw in that model and create the whole thing from scratch. All right. So, but there's a lot of cool patterns. Some of them don't even need handles. You could just create the rollers themselves where you roll it with your flat hand. And they create, like here's a little honeybee one. Here's one where it says made by Ruta, right? Cookies made by Ruta. How cool is that? Good going, Ruta. But all kinds of little impressionable type patterns and stuff. Fun stuff. You can have some fun with it and all. Now, I've spent enough time in kind of showing how you could create vectors. And of course, this was just a little generic pattern, just threw some stars in there, but you could have some fun making some patterns and all. Um, we could come in and in clip art, I think in clip art, let's see here, texture area tiles. So let's see what we have under texture area. I don't think I have anything in my texture areas right now. Probably not my VCarve Pro. I'll show them to you in that. But sometimes your textures, and I don't have all the models that you guys and girls have, but there's all kinds of brick textures, all kinds of textures you might be able to use. But typically you're kind of drawing them yourselves. Now let's get into the tonight's project. Now this was not tonight's project. Tonight's project we are going to make a basket weave bowl, kind of looking thing out of that big old slab of wood. So it's going to look something like that when it's all said and done. All right, I'm going to show you how we make this from scratch. All right, all right, all right. Now I'm thinking about actually taking this and taking it on the bandsaw when it's done and cutting this part loose and making a lid where a lid sits on the top of that. And then this, if I cut this lid off at the bandsaw, this part right here should fit under my CNC to where I could actually mill out some of the inside to kind of hollow out the inside. If not, then, I'd have to be creative. I could use a Forstner bit and just hog out all the waste material in there and then some fine sanding. I could use rotary tools. I could use all kinds of things. I could take it to a lathe and, chuck it up. But I won't be able to hollow it out on the fourth axis. I'm going to have to hollow it out on the table, lathe, by hand, some way or another. So it's going to be a solid block that looks like this, solid block. And, then it'll get cut down. But I'm going to show you we're going to make this weave pattern, show you how to do weaving and all that stuff. So we are switching over to Aspire for this, okay? And for those of you that don't have Aspire, please stick with us because learning how to draw vectors or create things or patterns and stuff, you might find it useful. All right, and all. All right, so in this particular project here, let's go back to our job setup here. This job set is a rotary job. It's 4 3/4 inches in length. 4 3/4 inches in length. Okay, that's because I'm chucking this bad boy up on its side like that. 4 3/4. And this thing, I mean, look at the size of my hand. That's a big old chunk of wood right there. But 4 3/4 from one end to the other, and it's 6 inches by 6 inches. But notice I have 5 7/8, right? Because when it gets rounded, the corners get knocked off and it gets rounded. I'll get a 5 7/8 cylinder out of that. Okay. Working from the cylinder center axis, bottom left corner, and wrapping along the X values. Ooh, that fell and it scared the Jesus out of me. Did you see me jump? Lord have mercy. Almost shot somebody. You could see my hand right now. I wear appendix. I was like, that's why it's coming in at me. All right, you got to be quick on the draw. All right. That was just, yeah. Anyway, scared the shit out of me. That's funny. All right, let's get back to it. Let's get full screen so y'all can see it so you're not looking at me jump like a freaking freak. All right. Rotary axis 4 3/4 by 5 7/8 inches in diameter. Cylinder axis for the center, Z0 is the center, is what we're going to zero off at. And bottom left corner and wrapping along the X axis. That's the same thing that we had set up in Pro. Okay. Now you're going to see a series of vectors over here, and you're going to see our material is actually here, right? There's nothing on it right now. But I have a series of vectors because I want to talk to you about weaving and all that wonderful stuff. So imagine a weave pattern, right? You have a series of whatever shape it's going to be. In this case, I kind of simulated some rectangles here. and we'd have one part going over the other. So it's almost simulated where one piece is going under and one is going over to create that basket weave. Hard to imagine when you're looking at a 2D vector, kind of imagining that, but imagine it. And if I were to trim this up to make it look like it was weaving right on here, I would do something like this. Let's see, this would go under, and so over, right? And then over, and then under, and then over, right? So you can start, oh, you can start to see that weave coming in, right? So over, under, over. Ha! I went over and over and over again. Hold on a second, I gotta fix my weave. Draw a line from there to there, space bar to finish. From there to there, space bar to finish. And get back to our trim. Boom, boom. That kind of thing. Over, under, over, under. And same thing, you know. Now this guy's just this makes no sense, Laney. Hold on, let's undo that. I had it right the first time. I went the wrong way. From the top there, boys and girls. Over. This one's under. Over. Oops. Wrong one. And this one's under. Now we're getting somewhere, Laney. You're doing it now, buddy. All right. So under, over, under, over. All right. So just by drawing those rectangles and creating that, doing some trimming, it kind of simulates that weaving pattern, right? You wanted to V-carve that, you could. We're going to be creating this kind of effect, but in a modeling form. All right. Y'all thought that was pretty slick, didn't you? All right. Okay. All right. Let's get back to it. Okay, so we're gonna do a weave effect around our bowl, but first I gotta kind of figure out what the bowl shape is gonna be. And so what I've done here is I created a profile. All right, so started off with not a polygon. I started off with a rectangle, and that rectangle here. Let me do it over here on the board. The rectangle was the width, that 4 3/4 inches, by the radius of my diameter, by half my diameter. So over here, 4 3/4 by 5.875 divided by 2 equals, click apply. Okay, get that in there. And then I was able to do some trimming, node editing, get rid of that bottom span. We don't use the bottom span. And wanted to take and turn this into a Bezier curve, pull this down, give this a little bit of a curve to it, go into the fillet tool, not 3/4, I want a 1/4 inch radius, and click on that, give that a little bit of a rounded edge there, go back into node editing and play around with this curve a little bit more, get it kind of like a shallow neck a little bit, and pull this bubble out a little bit more. And when it was all said and done and everything, I have a profile now that can get swept along the edges of the material here to create what's called a two-rail sweep. It's a model tool in the Vectric software called a two-rail sweep. Now, before I could sweep a profile, I need my rails. So I'm going to draw a line from the top of my material to the bottom, space bar to finish, top to bottom, space bar to finish. Now, I'm going to go ahead and pretty close, right? I'm going to use this profile here that I created earlier, but pretty close, pretty similar in style and everything. But one of the things that you'll notice as is that this one, if I were to drag it over and snap it here, is significantly shorter than this one. Why is that? Because I was at the half a radius, but I added some bulk here, right? So I added some bulk here. So I need to be half of that diameter of 5/7/8, and now I'm not because I added some height here. So if I were to measure that bad boy, or not measure, but look at the size here, I'm way over my radius. So what I did was simply took a guideline and snapped it to the top here. Y'all with me? You with me? You with me? All right. Right click, relative position. I want to go down 5.875 divided by 2 equals. Put a minus sign there because I want to go down. So when I click that, it's going to create that extra, line there. And then all I did was I went into node editing. Well, actually, I didn't go into node editing. I just drew a line. Drew a line right straight across that guideline. Get rid of that guideline there so you can see it. And let's move my actual profile I'm going to use out of the way. And then all I simply did was trim, 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 and then pop back into node editing and simply delete that bottom line. We don't need it. And that's how I ended up with that shape. And, you know, we're fairly, uh, don't do that. Don't do that when you're in node editing. We're fairly pretty close. I was just, my neck is a little different, from the original to there, but, same type of thingamajigger. So draw your profile, whatever it is you want to shape. And I want kind of this vessel type profile is what I want. So we'll drag that over here. All right. So I've got a profile, got 2 lines, 2 rails sweep. Open up the 2 rail sweep tool. Select our profiles, this one first, this one second. That is our drive rails. Okay, make sure those arrows are facing the same direction. If those arrows were not facing the same direction, then it would twist the model. Twist it. You don't want to do that. So make sure that their arrows are flowing in the same direction. We want to sweep. All right, so that's my drive rails. And then now I'm going to select my profile. Well, here, hold on a second. 1, 2. Hold down that shift key there, boys. 1, 2. Use selection. Then we're going to select the profile. No need to hold shift key or anything like that. Just select your profile. And we're going to scale it, the cross sections with the width. So, scale it with the width. And I already made my profile to match the width. And I want to sweep it between those 2 spans, between those 2 lines. We're going to go ahead and click apply and sweep it along. Dean, you'll have to let me know about my skeleton running around the shop, what that means. Am I missing? Am I part of a joke? You guys making fun of me while I'm not paying attention to the chat over there. We're gonna answer some questions here in just 2 seconds. We're gonna come over here and let's unwrap this so we can see what we created. We basically created a piece of trim, right? That simple profile. We swept that profile along that rail, right? And if we were to wrap it up, we'd have our vessel. Just a very simple plain vessel. Now, I want this to kind of look like a little weaved basket on the bottom and all. So I want to add some weave to it. Some weave and flow, weave and flow. Now, when we're doing the weave and everything, we're going to basically be taking a profile that we draw and we're going to be sweeping it along a center rail. So I like to call it the one rail sweep, but the center rail, which basically this tool allows us to take a profile and sweep it along a single rail through the middle of a single rail. But we also have a function that we can actually weave multiple cross sections together. So multiple lines and patterns and stuff and everything. So let's go back to our drawing tool and let's see, our pattern here. Now, when I drew out this pattern, there was actually a reason for drawing out this pattern of rectangles and everything before I created the weave, is I wanted to kind of look at my spacing and everything. And imagine a center line running through each of these vectors and stuff, and all. And I wanted to kind of get a spacing, to see what size profile that I needed to create or wanted to create and all. And what I ended up coming up with was this little guy right here. And so this little profile right here, let's close this tool, come back to our drawing tools. This little profile here is 1/2 inch wide. And at its highest peak, it's 1/8 of an inch. So from the highest peak to down here, it's 1/8 of an inch tall. All right. And simply to make that, I drew a rectangle, right? Drew a rectangle. And on that rectangle, I made it 0.5 inches wide. And I didn't care about this number right now. I just created the rectangle, get it made, because I wanted an overall height of 1/8 of an inch when it was all said and done. But once I did that, then I came in and I drew 3 circles. I drew my center circle was a 1/4 inch, I'm sorry, an 1/8 inch diameter. And then I had an outer circle that was a 1/16 of an inch diameter. And what I did is I figured out kind of where I wanted this outer circle here. And then I took a line, and in the center here, I just drew a line straight down. And that line allows me to flip this model over to the other side, or not this model, but this vector over to the other side, equal distance on the center. So I can go into my mirror tool and create a mirror copy. And if I select that object and this line, I can flip it about that line and get it equal distance on that side, right? Once I did that, I then came in with my scissor tool and trim, get rid of, oops, not that. Let's zoom in here, trim that away, trim that away. All right. Now I needed an overall height of 1/8 of an inch. So I came into my size tool and I kept my aspect ratio different. So 1/2 inch. So I unlinked the X and Y and changed this to 1/8 of an inch. 1, 2, 5. Click apply. And what that did was not only did it string it down, but it gave me kind of this little, almost like dome shape and everything. This was slightly different and all. And it's all based on, this overall height and everything. If I were to squish this down even more, the more I squish it down, the more domed it gets. It all depends on how, big you want your beads and all. But when it's all said and done, if I were to do that and say, I like the way that looks, then I need to, come in here and get rid of that span right there and get out of node editing and drag a guideline to the top of that, right click, make a relative guide 1/8 of an inch away, negative, because I'm going down, create. And then, I need to extend these out to our, this line here. Now I can just simply use a line to help me extend, because if I draw a line there, now I have something to extend tool, and I can use my extend tool and go boom, 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 boom. And then I can get rid of that line. I only needed it just to help me extend. So now I'm at 1/8 of an inch with my little dome shapes. And so that's how I came up with this profile. Very simple enough, right? All right. Now that we had the profile and everything, and this profile is bigger than my little square boxes here, my little simulation. But now I have to come up with spacing and all. So imagine on this profile a center line running down the middle of it. Okay. Don't have to imagine because I just drew it right there. And so what I had going on here was, you know, I wanted to figure out, kind of what spacing I need on based on the area that I wanted to cover with the weave. And in that general area, what I came up with is from the kind of the bottom edge, it's going to be a half inch in to the center of the first, weave. And then from center to center, 3/4 of an inch apart, and then another half inch, to the top part. And that's what gave me kind of my guidelines here. I drew the lines based on the center because we're sweeping across the center, and I drew those lines and I stretched them out all the way to the length of the material, you know, and everything. All right. And then I drew a line kind of based on that similar spacing, you know, and then I ended up just offsetting all the way across. And I wanted to end up with, that equal spacing on the top and the bottom just to create this kind of grid here. Now you'll notice there's another line way out here all by itself. Well, that line is for this little profile here. This little profile is a rectangle, bottom cut out with a little radius fillet on this end. Kind of create a little cap that, when the weave is carved and on, it's hard. I can't do it like this, but imagine it's going to cap off these weaves here on the verticals and all. So this little profile will get swept there. All right, now we need to put it all into motion, into place. So I'm going to grab all these vectors. Okay, let's do this again. Get in the middle of the screen there, Hoss. Grab all these vectors, and I'm going to snap the bottom to this edge and the top to that edge. Okay. That's going to be my little, what I'm going to sweep these little profiles here. Let's get rid of that little line in the middle. I'm going to use these two profiles with my single rail sweep tool to create my weave. Weave and bob, weave and bob. All right. So here's how we do this. We're going to select our lines 1, 2, 3, 4. And then I'm going to use the power of the mouse, draw a line in from a box right to left, hold down that shift key and select all of them so it selects them all. All right. I got all my weaves here. Now, if I go into that modeling tool and open that single rail sweep, I like to call it, but the center line vector tool, that's going to be my selection. What I have selected is my drive rails. So you'll see all the green nodes, all the little starts and everything. Now, my pattern that I want to weave or not, or that I want to braid, crisscross, if you will, is going to be this vector here. And I want to, I don't need sharp corners. I want to sweep it between the spans. Okay. And if I were to click apply, just to show you, if I were to click apply here, let's go into our 3D view. Let's unwrap this. Okay. It would create this grid, right? Nothing sexy about that at all. It's just a funky grid. Well, I need this to weave. I need all of those different profiles to weave under and over, under and over, and under and over. So we have a very cool tool here called Weave Under and Over at the crossings. So I'm going to select this. And on my Z, I'm going to Z under, it's going to be 0. And my Z over, I want to go, when it goes over, I need to go over by 100% of that little profile, 100% over. So I'm going to go 100% and click apply. And so there's our pattern. Now, what does the over, under, 50%, 30%, all that stuff take and mean and all? If I were to adjust this, let's say I went 50%, then my parts, oh, I'm sorry. If I went 50%, always got to be 100 on the over. Um, Basically, it's cutting halfway through, right? It's not going 50, it's not going 100% under, it's kind of going 50%. Even though that the top one is going 100% over, the bottom one is going 50% under. So you would change your ratio however you need. Now, I could also, I'm doing scale the shape, right? I could say, well, I want to keep the shape. I don't want it to, like, if I go 0, which is what I want, and click apply, watch how the shape, when it regenerates, watch how the shape, it starts to flatten out, like literally, like it looks like it's getting flatter as it goes under and then, bulges up and everything. So it's flattening out. Well, I could have done add base to that. I could have, add base where it just adds meat, for the over under instead of scale shape. And it keeps my shape the same, but it adds meat, it adds base, meat underneath. So it keeps my shape the same, but it has to add meat underneath to get it to raise over, and it kind of blends them together and stuff and all. And I could change this. Let's say I said add meat to that and make this 0, make this 100%, and click apply. And then what it does is on the over, it adds base, that all that meat, right? And it doesn't look right. It just looks like it added thickness to it so it can get over to keep my shape the same, and all. So I like the scale shape, 0 under, 100% over. I want 100% of that shape going over the other one. And click apply. And that's going to give me that true kind of weave look, that basket weave look. All right. All right. And now, because it is wrapped on top of the existing model that's underneath, that weave is actually taking on the shape. It's an add mode. We're adding it to the component, the previous component, the component that's underneath it. Right. And so if I close this, if I were to get rid of that lower component, right, I'd have just a weave. Right. And I could do a weave leg or what have you, whatever the case may be. I'd want to add a 0 plane to that, so it kind of fills in and all, but, I could do a weave of that sort. Now, in the case of this, turn that off. My weave is actually following the shape that's underneath it. It's being added to the shape that's underneath it, and the shape that's underneath it is my vase, my vessel, my whatever the case may be. So it's kind of giving that weave basket look. All right, now I don't want these ends just kind of dead ending like this. I want to cap them off some way. Brings us back to our drawing here. So I decided to create a profile that when it caps them off, it'll square off and cap off at the end, and then it'll just kind of round in to my neck, my shallow area here and all and stuff. And so again, this was my drive rail. This was my profile. So again, that single rail sweep tool. This is my drive rail. That's my selection. This is my profile, and I want to sweep it. It's not really between spans, but I want to sweep it along that span. And click apply. and it'll sweep that profile. Now, if we go into the 3D view here, basically what that does is, let's get to the end here, let it regenerate, is it creates this end cap that kind of floods into this, just rolls over into the neck of that model area and all. So it creates that end cap. That's all it does. Now, when I wrap this up into my cylinder, it looks like this. Let it regenerate. And let me zoom in a little closer and let it regenerate. Almost there. There we go. And so I've got the weave pattern, and then it's a nice clean rim. And when I created that, it made me think, which I didn't have the intention to, but it made me think, man, okay, I'm gonna cut that off and create a bit of a lid, if you will. All right, a lid and stuff, and where it just kind of sits on there and all, and then I'd have to, run it through the bandsaw and then create a lid on that. And I could be a little bit more decorative. This I could flare this end out a little bit more, or what have you, depending, to make it more look like a stopper or what have you. But I was happy with this shape for what it's going to be cut out of. Okay, and so if you're ever interested in, making weaves and, you've got Aspire and you're trying to figure that out, it's the single rail sweep tool. And weave over and under. Now, on this, the tool pathing is the same way as it was in the Vectric software. The only thing that we used the Aspire software was to be able to create this model. The two rail sweep tool being able to take that profile. If this was a table leg, if it was, whatever the case may be, I can create that profile and sweep it between those two rails to create whatever, shape that I want. Being able to do that allowed me to create this weaved basket, um, and it wasn't my intention to make a weaved basket, but Javier, I was talking with Dave Gatton and the gang the other night, and they asked about Javier asked about a weave, and I said, "I'll show you that in the class." And so then I started laying out the weave, and I thought, actually, that looks pretty slick. I want to make that kind of into like a little vessel, and that's what what we ended up with. So no matter what you end up with, whether you use Vectric, VCarve Desktop, Pro, Spire, you build your own models using your clip art, you import a model that you purchased online, or Aspire, you do the same thing. You can import models or create your own. Basically, I laid out my vectors, created my profiles, and through a matter of sweeping on a two rail sweep and then a single rail sweep, I was able to sweep those patterns across to end up with what we've got. Now, for those of you that are interested in like V carving and all that stuff, and like making a faux weave pattern and all, you could just like I did. I just drew rectangles and you just trim up your vectors and all, and um, they're open vectors, right? You would have to kind of close them off, and you could create that simulated weave. Um, so what I mean when I say close them off, this is an open vector, right? We cut away these lines. This is an open vector, so you got to close them off. So that's the join tool for those of you that are curious. Join tool down here, join with a straight line, just to close that off, right? Same thing with this one, join with a straight line, and you'd have to go through on each of those and join with a straight line and close them up and everything. So join with a straight line, with a straight line, and once you had those vectors closed and all, then you would probably want a little bit, not much. You probably want a little bit. I'm gonna hold down the control key so it's micro movements. A little bit of space between each part. I'm using the arrow keys and my control key. I'm holding it down and just creating a little space so there's not that overlap and everything. I got one here. That little micro space and all. And you would do that, and you'd have to kind of, start your way at the bottom and work your way up or what have you. But if I were to carve this as an example, VCarve, our toolpath. Hold on a second. Bear with me a second. I would need a boundary around it. Give me a second. Wasn't quite a VCarve toolpath. Profile cut would have done the same thing, but let me get this sized down appropriately, and then I'm going to make it just a little bit bigger all the way around. All right, one more time. Turn this vector off. All right, so VCarve toolpath. Oh, I know there's an error. VCarve toolpath. Oh, hold on a minute. It's not going to let me do a VCarve toolpath while I have this turned on. There we go. My model's too big for my material right now, so it wouldn't let me do a VCarve toolpath. Let's see here. 0 start depth. I'll go with for right now, a 16th inch flat depth. We could use an end mill, 1/8 inch end mill. Calculate. It would help if we actually did that on the board. Hold on a second. Let's move to a new layer. Turn that layer off for a second. And let's bring it on the board there. Now we can do something with that. Calculate that toolpath. Unwrap this. Are you not going to work with me here? Let's see here. Between. Bear with me. There's a method to this. What? Let me do it as a profile toolpath. 0.0625 on the line. Oh, you son of a. Oh my God. I love when I try to show you guys something. I had a dovetail bit in there, not a V bit. Even I screw up too from time to time. All right, let's calculate that toolpath. Reset the preview. Now, of course, it would look better if I had, the other weaves and all that, but all right, so we've got that part. And then you'd have to go in and pocket out this stuff here. Which was that first toolpath that I just created. And anyway, you could simulate kind of a weave pattern. I'm not doing it right. I think it's going to be a ball nose bit, not a V bit, but you could V carve a weave pattern. I might make that another class, so we're not wasting time on this. But in a 2D environment, you could create a faux weave if you had VCarve Pro that. And I got to focus on that one. I wasn't prepared for that, and there's some thinking behind it. But it can be done. Anything can be done. All right, let's turn this back on. Jesus, that was a successful showing of what not to do. All right, let's see here. We got to go into our job setup. We had an error. Our overall diameter, right, exceeded our limit. And why did it exceed the limit? Because of the vectors, the weave. I didn't take in account the height of the weave, that eighth of an inch. I didn't subtract it from my profile that got swept, you know. So on that's this guy right here. So if I go into the properties here, I have my overall shape height, of this guy. I should be able to subtract the eighth of an inch. It's actually going to be more than that. It's going to be a quarter of an inch, eighth of an inch on each side. Remember, it's wrapping. It equals. Let that regenerate. Let's. I'm not screwing up twice in a row. Let me see here. 3.058. Let me find out what my radius is. 5.875 divided by 2 equals. Okay. And so, easy breezy. 3.0586. 3.0586 minus that equals. That's not what I want, but that's what I needed to reduce it by. All right, so copy that value, reset the height, and then subtract that value that I copied. Equals. Let that regenerate. Come on now. Regenerate, you son of a gun. Why you messing with me, man? 5 point. Close. Okay. Sorry. I had to regroup. So I was trying to change the component height here, but I wasn't taking into effect. I was taking into effect the eighth of an inch, but there was more meat of what was underneath it. Here, under the weave, there's meat there, so it wasn't a true eighth of an inch. It was actually more, and then I had to, go from there. So easy for me to just click set here, take my diameter, divide it by 2 to get that radius, and size it to that radius so that it fits, my whole diameter. So I went the long way around, couldn't get to it, so I ended up just taking the shortcut, which I should have done to begin with. So I apologize. That was I wasn't taking into account. I was taking into account the eighth of an inch on both sides, which is a quarter, but I was not taking into account the meat where the underweave goes, and I don't know what that height is. So without doing a lot of poking and prodding with my mouse and finding that height, when we're in a unwrapped uh 2D view, if you look here on your bottom at the bottom as you move over your mouse, you can kind of gauge what the height is, and it's a pain in the butt. So it would have been not conducive for me to do that. So what I ended up doing was taking my diameter divided by 2 and just rescaling the model to that height. Done and done. Okay. So everything still looks good, and it's going to carve. Oh, sorry. It's waiting for me to do an action over here. Click OK. No, I don't want to recalculate the toolpath. All right. So it's going to carve like that. And 3D rough cut using the material as the boundary. Use a 1/4 inch end mill. I'm going to have a 40,007 inch allowance. I'm going to Z level raster. Let's unwrap this and let's calculate the toolpath. And then while that's calculating, let's answer some questions. We haven't got to a question all night long. Let's see here. Oh, I did answer one question. I answered Roger's question. Does this have a start time? That was a good question to ask or answer. We're letting that calculate. I think you guys were just having a good old talk with yourselves about your states and stuff. So I don't think there was a whole lot of question. Mike did ask anyone here who does not have a fourth axis. I'm sure there's a lot of people, Mike, that might not have one. Um, Dennis Robinson, you're waiting to get yours hooked up. Very good. Let me see here. As for the fourth axis, my plan was stop, get one. Oh, okay. Never mind. You guys are still talking to yourselves here. Hello, Laney. Looking forward to tonight's show. Hey, Jim. Robert Casa, did you ever get your echoing worked out? No. I'm looking at questions. I'm scrolling down. I don't see a single question unless I'm missing them. Let me see here. Oh, I got you, Dean, about the skeleton now jumping. I did jump when that thing fell. That big old block hit that floor. Um, how does Aspire not have this guy on the payroll and doing commercials for them, right? Uh, well, Vectric has they invite me out to their user group conferences. I was a presenter at Denver. in Denver, Colorado this past year, and I'm sure they'll have another one coming up in near future, and they may invite me again. Yes, make sure you save early and save often. So good. Thank you for that. I'll hit save and save that. All right. So the rough cut is finished calculating. Let's go ahead and preview that visible toolpath. Let it finish saving. Good teachers don't get questions. Thanks, Michael Bell. That's pretty good. I like that one. Uh, I worry sometimes that no questions mean that you guys aren't interested. So I'm like, okay, that means I got to come up with a different topic to make it interesting. But hopefully you found something interesting in tonight. Preview the visible toolpath. Um, I forgot to reset the preview, so I'll probably have a funky. Here, let me stop that. Reset the preview the visible toolpath because I had that weave fake bad carving in there. Um, but Ronnie, how long will it take to carve this out? Well, that's a good question, buddy Rowe. Because we're going to be carving this on Thursday. We're going to be making this on Thursday, or I'm going to be making it on Thursday. You're more than welcome to join me in the shop Thursday when we set up the fourth axis to carve. Um, there may be a little bit of movie magic in Thursday night's group. I might have the rounding toolpath done because we haven't even talked about a rounding toolpath yet. We're just creating the roughing and all. We're going to do a rounding here in a second. But I might have the rounding already done, and it all depends on because this is going to take a couple hours probably. But so the rough cut, just going to hog away that waste material, you know. Then we have a finishing tool path using the model as a boundary. I'm not going to do a offset, no offset on that, and I'm going to use a um, I designed this to where I could do a 1/8 inch tapered ball nose and still get a pretty decent look on the weaves and everything. So I'm going to use that. If I don't think I'm going to get enough detail, then I'll probably use a 16th inch tapered ball nose to try to get the detail out of it. But we're going to use the 1/8 inch tapered ball nose. And yeah, a raster. Calculate that. Let that calculate and go on any questions. Um, Crystal, good to see you again. How you doing? How you doing? How you doing? Crystal over at Calusa Cabinets. Am I saying that right? Calusa Cabinets. Um, yeah, nice on the spot design. Let's see here. Very interested in trying to grasp it. It's new to me. Yeah, Stephen. Fourth axis. Now you guys have your big shop saver, you and Crystal. And I'm assuming if you had a rotary axis, it would go on the table. So you'd be that example where it's carving, your router's carving overhead and everything. So whether you, depending on the fourth axis kit that you got, you could actually set it up to uh, span across your X axis of your table or that long Y axis of your table, however you wanted it to go. And then you would just be wrapping your uh, Y around your X or your X around your Y, depending on which way you orientated that fourth axis on your table. You actually have multiple clamping options on that larger table and all. Dean, Dean, you're a trip, Dean. Dean says, Laney, no questions means that we're mesmerized by what we just saw and are lost in our minds thinking about all the possibilities. For what it's worth, I've never been bored by one simple episode. Thanks, man. I appreciate that. Um, is Calusa, isn't that the county, Crystal, or am I wrong on that one? Or is that y'all's guy's last name? I can't remember now. I thought I knew the answer to that. Is that the county or is that y'all's last name? Do you remove your fourth axis when you're not using? Now, Rodney, I'm going to answer. Rodney, you asked another question up above about the carving time. As soon as this calculates, I'll let you know that. I think it was Rodney. Was it Rodney? That was Ronnie. Ronnie. Who was it that asked how long would it carve? That was Ronnie. Rodney says, "Do when you're not using it?" No, our on the digital wood carver, the fourth axis mounts to the side of the unit, and the router head pivots 90 degrees, and it goes over and carves, so it stays on permanently. As a matter of fact, if I went while it's calculating, if I went full screen, um, the fourth axis, the rotary axis, mounts to the side of the unit, and the router pivots 90 degrees to go over and carve that rotary axis. So it mounts off to the side, so it doesn't get removed. It stays on. There you go. Yeah, Caloosahatchee River. Yeah, the further south you go, those Indian names, um, Caloosahatchee. Yep, yep. All right. So on the finishing cut, what I'm looking for on this finishing cut when I preview this tool path is am I going to have any tool marks and stuff inside those weaves and everything? And we'll zoom in and look at them. Which I can see a few, not too many, but I can see a few. And those tool marks would mean that my bit just couldn't quite get in there to get the radius. So therefore, it's leaving the tool marks at the tip of that ball nose bit. So when you see tool marks in that preview on a 3D model cut, that means that the radius was just so small that the tip of the bit diameter was too big; it couldn't get in there and leave those marks and all. And so, um, in here, right hold on. There we go. In here, on the finish cut, in these areas here, these radiuses here and here, I've got some tool marks and stuff. And so I may be better served or best served by using a 16th inch in ball nose. And let's find out if we take a second and come in here and calculate this. Of course, I know I'm going to get better results with a smaller bit. It's just longer run times, longer, double everything. And we'll calculate that. Let that calculate while we go over and ask some more questions. Um, so any questions right now regarding VCarve Pro and working with a rotary job? Doesn't have to be Aspire. It can be anything. That's why I was kind of jumping back and forth between the two projects. And let's by the way, when you're looking at the 3D view, your material setup, you got to make sure when you're in a rotary, that little tan area, that's the model, right? You want the model on the outside of your cylinder, not on the inside. You want it on the outside of your cylinder. You see, so it forms appropriately. Okay, you want it on the outside. So let me regenerate this bad boy. Get my zero plane in there, turn that on. So it wraps up. There we go. So any questions on anything on the roughing pass? Will the tool take a bigger bite on a piece of square stock when it gets to the corners. Yeah, Stephen, but we haven't done the rounding toolpath yet. I'm letting this 16th inch bit finish calculate, and then we're going to talk about the rounding toolpath. Um, and all. And as a matter of fact, we can actually talk about it in here. So along with the 3D rough and 3D finish, we still got to do a rounding toolpath. So we got to come up to gadgets, the wrapping gadget, and we got to do a rounding toolpath. Now, when we do a rounding toolpath, if you're starting off with a square blank, put in the size of the square blank. In my case, it's going to be, in this job, the little spindle, it was 2 inches, right? If I was starting with an already rounded cylinder, then put in the diameter of that, rounded blank, In my case, I'm starting with a 2-inch square blank. Now, when it comes to the rounding toolpath, I could do a radial rounding, around and around on that cylinder machining method. I could do a raster where it goes back and forth along my x-axis, back and forth as that little head turns. Or I could do an optimized raster along the cylinder, which machines off the corners first. And since I'm working with a square blank, I want it to machine off the corners first. And what happens is in that rounding toolpath, and I'm going to use a 1/4 inch end mill or 1/2 inch or what have you. I like using bowl bits. I'll end up using a bowl bit to round off mine. But the bigger the diameter, the less time it takes to round things off. But to answer Steven's question about, hey, will it take a bigger bite when it takes the corners off and all? Um, Imagine, if you will, that we have our square blank here, and I'm going to go 2, comma 2, enter, and create that 2 by 2 by using the keyboard shortcuts. And let's take, and we have our router bit, our collet, our router. Put that bit into the collet. All right, get everything all centered up. Oops, not that way. That way. And group it together. G for group. All right. So imagine if my 0 is the center of the stock, right? And so I'm zeroed out from center. And so my router has a safe distance that it's going to back away from that center. And in this case, it's 1.4375 inches. Okay. So let's say it backs up here, or it backs up to it, that safe distance and everything. Well, if it were carving right on this edge, well, when this part, goes to rotate, man, it would be taking a big old bite on those corners and everything, right? So what the optimized rounding toolpath does is that it will what it does first is it rotates the part, not that part, rotates this part to that first corner, and the bit comes in and takes its normal pass depth, whatever it is, 1/8 of an inch, 16th of an inch, whatever you have your bit set for, and it knocks off that corner, and it will turn appropriately. Here, let's draw a circle in here. 1.875, 1.875 D for diameter. Okay. And so it will mill that corner, and then as it's taking its passes in, whatever steps it in, this piece is rotating just ever so slightly in these two directions. It'll run and clear off that, all the way until that corner is completely brought down, you know, to its diameter. Once it's done, milling that corner, then it will take the part and it will rotate it to the next corner and do the same thing, then the next corner, and then the next corner. And once it's finished doing all the corners and getting them optimized off, then it's going to come in and do the actual rounding toolpath where, that part is getting milled down round and everything. So it optimized, it takes the corners off first. So with that tool, with that rounding toolpath with the optimized corners, it's not going to take that big bite. It's going to take normal bites, Stephen. So that's the option. And when you're starting off with a square blank, that's the option you want to use. Um, and all. And Rodney says, I have a 1 inch ball nose never used. Would it be good for rounding? Sure, absolutely. The reason why I like bowl bits and ball noses are even good too is they're rounded. They have that radius. They're not flat, and so it when it's milling off and taking when it is taking a bit of a bite, it's um it's not taking so much of one. And when that bit is spinning, imagine, if you will. Um, Let me back this up some. Imagine, if you will, the oops, and the same kind of applies with a uh, oops, you son of a gun. Oop, you son of a gun. Get over there. You oh, it's duh, it's grouped together. You can't trim a grouped object. There we go. And let's radius the corners. Let's say 0.25. But, oh, that's why it was a dog bone fillet. Normal fillet. All right, so imagine we have a bowl bit. That's my interpretation of a bowl bit. Um, the When that bit is spinning, and I can't rotate this direction, but when that bit is spinning, when it's taken off, the corner and everything in here, by being rounded here and not being so straight edge, that point on that edge isn't digging in to the upper level here. It's got a nice gradual radius, so it's kind of more of a scoop and everything. So, and ball nose bits are the same way with their radius. So, yeah, a 1 inch ball nose bit would do just fine for that. End mills, quarter-inch end mills, sometimes I use and all, but I do like using the bigger diameter bits and all, and everything. And if they have, rounded edges and all, that's great. Bull nose bits are great for rounding and stuff. Bull nose. Uh, all right, let's see here. Question. Okay, question. Okay, question. So if you were to leap before you look and buy the parts for a fourth axis, do you also have to spend 2,500 on Aspire in order to use it? All right. So first of all, Dean, if you do have Vectric VCarve Pro, it's $1,300 to upgrade to Aspire. If you have desktop, it's 1,625. Um, so you wouldn't, if you already own one of the two, you don't need to pay the full price of the Aspire. You pay the upgrade price, the difference. Second of all, no, you do not need Aspire to use the fourth axis. That's why I'm in Pro right now demonstrating, creating these 3-axis models and things uh, and stuff for, you know, your fourth axis. You can do it all in Pro and all, but you got to use existing models. You can't create from scratch. Like, you wouldn't be able to create that weave pattern from scratch. You can use the weaves they have in the clip art weaves, right? They have different weaves and stuff that you can use, different sampling and all. You can use those and everything. But you can't create from scratch to be able to do something like I was doing with the 2 rail sweep and the 1 rail sweep. But yes, you can use Aspire and Desktop to create a rotary project. You don't need Aspire. Aspire just gives you the ability to do extra customizations and things and all. And speaking of Aspire, let's pop back over here and let's look at our, it's still calculating. Oh God. Based on that, using the 16th inch end mills, not gonna be the way to go for me. Holy cow, things take forever. I saw that question. Um, let's see here. Uh, okay, that's a heck of a name for a river. Yeah, Cecil. Yeah. Um, there is oh, I laugh every time I go down that way. Um, it's beyond Jihad Junction. Um, yeah, once you get further south, the Native American names for the counties and the towns and things are very uh, pronounced because the Seminole Reservation is down there in Immokalee, um, outside of LaBelle and all. My cousin lives on the Indian reservation. My grandfather's my grandfather's mother, which would be my great grandmother, is full blood Seminole. And Paul Swamp Owl is his Indian name. He lives on the Indian reservation down there in Immokalee, and he wrestles alligators and all at Billy Swamp and Safari down there. He's one of the handlers, the gator handlers and all. Fun stuff. All right, coming along. Racing along there, guys and girls. All right. So, with that, if we come in to let it get into the preview, what we're going to do is when the preview comes back up, all right, I'm not going to reset the preview. I'm going to just zoom in nice and tight here, and we're going to preview the selected toolpath. And as it comes along, we should be able to see when it gets into this window view here, we should see these areas here start to disappear and clean up. So let's watch as it progresses. And you should see that line moving right along like a little invisible line right there. And so these inside and outside corners, that radius can get in there. Should see that line moving along. So that detail and everything, it's able to get into those tighter radiuses and stuff and, you know, clean it up. So it's going to be more appropriate for me because that's a nice piece. I don't know what it is. It's a nice piece of wood. I don't know what it is. But I want to say it's beach or something. I don't know. We'll figure it out. But I'll ask my forester guy that sends them to me. He sends me a bunch and he doesn't label them. I'm like, man, what is this? What is that? So he sent me some really cool things before. And I've always wanted to do a fourth axis with that one. I just didn't know what to make. And this gave me an excuse to come up with a cool project. And then, of course, Javier asking about the weave gave me the idea of this kind of weave pattern basket based on this. And I thought, you know what? Hey, it's all coming together now. So there's a reason and a rhyme for everything. So once this calculates and all, we're going to talk about the run time. And the one thing that I was telling Stephen in the VCarve 10, well, even in the Aspire now, we still need to do a rounding toolpath. So wrapping, create a rounding toolpath. My stock diameter is going to be 6 inches by 6 inches. Going to do that optimized raster, and I'm going to be using my bum, 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 bum. Oh, the one thing I'm kind of disappointed with is I, the way the Vectric shows. Only certain tools can get shown by the type of tool they are. Um, it's not showing my bowl bits now. It's showing only end mills and things. So I'll just go with a 1/2 inch end mill. And see, I could cheat the system and create a end mill the same diameter as my bowl bit and just use the bowl bit in the router, but that's all right. We'll just go here. Now, you'll have to bear with me a second. Click OK. Okay. So now I have a rounding toolpath. That's going to be first. This bad boy, this bad boy, this bad boy gets removed. They don't belong in here. That's for the VCarve samples. One of these, I'll come back and I'll figure out how to weave a VCarve weave. We'll create that next week or something. Delete all visible. All right, we got a rounding tool path that's going to be about 35 minutes to carve based on my bits, speeds, and feeds. Now, again, if you were in something like the Shop Saver 4x8 commercial machine or our 51 DWC 5100 commercial machine, man, you could run a few hundred inches a minute. But I'm running 60 inches a minute with this. The 3D rough cut is going to be about an hour and 19 minutes. And the 3D finish cut, this is the one that I'm dreading because I have a feeling it's going to be a big one based on that weave and that size of that bit. So I have a choice. Sacrifice a slight amount of detail and do it in about 4 hours, or go full on detail and do it in 8 hours, an 8 hour run. Um, if this is most likely, I'm going to have to um, run an 1/8 inch end mill because I'm going to be carving this most of it. Be carving most of it during the live event, so you guys can see it carving on. I'd like to have it like a quarter, like almost all the way done. We're only like maybe a half hour running and it's finished, so we can take it off and look at it and all that stuff. So I got to do a little bit of movie magic, a little bit of prep work. I got to do the rounding toolpath off a camera, the 3D rough cut toolpath off a camera, and either the 4 or 8 hours. Probably do about 7 hours off camera or whatever, and then maybe the last half hour while we're talking and all, we can carve. But I also want to be able to show you the setup, like the digital wood carver for the digital wood carver folks, how to tilt the router 90 degrees, how to zero out everything and stuff. So we got to kind of do a little bit of movie magic on a blank and also. Tippy's like, I would watch for you, Tippy. It would be just me and you, buddy. There would be nobody else, and nobody else sitting there for 8 hours watching that thing carve. Um, I could always do a live stream from the shop where there's no talking and no volume, and it's just the camera pointed at the CNC to where it's just streaming constantly. Just like carving this from start to finish. That would be an interesting thing one day. But yeah, Tippy, you and I'd be the only ones. Um, but yeah. All right. Um, any questions about this project? Let's wrap it up so we got it in a kind of a final view there. And let's tilt this up uh, this way. Let it regenerate. Just not that much. Let it regenerate, and that's going to be our little basket piece. And like I said, off the CNC, I may use the CNC to get this to a certain point. Off the CNC, if I all right, so imagine if I have a lathe, right, with a 4-jaw chuck or something like that. I could take this off the lathe on the bottom, right, the bottom base here. I could take my little center hole because I'm going to be working with a spur drive and a live center. I could take a Forstner bit, a decent sized Forstner bit, and create a little recess in there that my 4-jaw chuck can grab onto. And then I could use my hollowing tools and stuff, and I could hollow out the center of this and make a vessel. On my CNC, depending on my CNC's Z height and clearance, with a long reach bit, I could, which typically long reach bits around 4 inches, 4.5 inches in length. I could set this on the table, and if I had that Z height, I could just hollow it out, pocket it out on the CNC table. Or I could do it by hand. I could take a drill press or a Forstner bit or whatever, and just start hogging out all that center area and stuff. May need to take a Dremel tool with a burr tool and all, or what have you, in there, and do some Dremel work and all, and some sanding and everything. And I could hollow out this vessel and stuff. And so, not sure exactly what hollowing method that I'm going to use, but I do know that when it's all said and done, I am going to, right at this seam line here, I'm going to take it to the bandsaw, and I'll have to build a jig that can hold it nice and true and everything, but I'll end up hacking this off. And what I may end up doing is uh, just having it where it's on the inside of the lid. I might kind of do a little bit of a cleanup on the inside edge, so when this sits down, it sits down inside and it kind of rests inside, just like it looks here. But I might have to do a little bit of inside sanding around the rim so it kind of sits. It recesses down in there, because I can't do an undercut. When that router bit's coming, it can't undercut that round over there. So this round over just transitions right into this. But I could undercut it with a little sanding around the edge, so that when I do put this lid back on, it rests inside that ring, right? And I could hollow this out and create a nice little cool little vessel. There's a lot of ways to, the CNC can only get me so far. Not everything has to be done on a CNC. Um, and everything. And that's what we have other tools in the shop for. And there's a lot of different methods. Approach it by hand, Dremel and Forstner bits and hole saws, whatever, hog out that center part. Or throw it up on a lathe if you have hollowing tools and stuff, and hollow it out that way. And all. And uh I had a friend who one of my best friends here in Ocala. He and his wife just got married, and she loves turning and everything. And he wanted to get her a lathe. And I had a lathe in my shop, and I have my fourth axis. Well, I use my fourth axis primarily for anything, and the only time I use my lathe is when I was turning pins and things like that and stuff. And with the uh, with knowing that and all, I told him, I said, Kevin, here, and I just gave him my lathe. It was a jet mini lathe. Um, and I gave him all the turning tools and everything, and my little Wolverine tool grinder and or sharpener and all that stuff, and set him and his wife, and his new wife, and man, she turned some cool stuff. They're having a blast with it and everything. And I just gave it to them because I didn't use it very much anymore when I got the fourth axis. I very rarely used it unless I was turning pins or something. Um, but with seeing this and everything, I may, go, hey Kevin, I need to go over to his shop and borrow the lathe. I might hollow it out that way, or I might just end up at some point in time buying another mini lathe, the jet mini lathe. I like the jet mini lathe; they're pretty cool. I don't want a big lathe. I don't need a full size lathe. Just a mini lathe is fine, and it should have the capacity to do this for 5 7/8. It might have the capacity. I think it does. I believe it does. I'm not sure, but yeah. All right, guys and girls. So overall run time, depending on how I go about it, if I cut the time in half with the 1/8 inch ball nose bit, overall run time for this project is going to be about 10-hour run, 10-hour run time. And I may do an 1/8 inch ball nose. I may calculate it, do another finishing tool path of the 1/8 inch ball nose, and I might run the first few minutes, first couple bits of weave, just to see what the weave detail is going to look like. And if I'm happy with it, then I'm just going to let it run out, and I'll cut the time in half down to 4 hours. And so, If I don't like the detail, then I'll just run the 16th inch finishing toolpath, one or the other. But I'll do a lot of that on camera. We will do setup, how to set up the fourth axis and zero out and everything, and we'll get everything kind of chucked up. But for the most part, the project is going to be done, fully done. Pretty much done. Maybe have to run about a half hour and all to carve and all. But we might carve something small as well. It depends on because we just can't do a 10-hour video. All right. More time is more money. Yeah. Now this is gonna sit up on my shelf. It's not gonna get sold, but yeah, more time is more money, and that's why 3D model cuts are very hard, especially with smaller machines and all because of run times and everything. It's hard to price them. Um, you don't want to overprice, and shoot yourself in the foot and lose a sale, but you also don't want to undervalue your materials, your project, and not your materials, but your work. You don't want to undervalue yourself, so it's very difficult to find that happy medium where you're making a decent commission on that project, but at the same time, you're not outrageous. Um, if I on this vessel, knowing what it is, hold on a second, I'm dropping stuff everywhere here. Knowing what it is, right? I don't know what it is. It's something, but it's gonna make a pretty bowl. I think the weave pattern with that grain and all, it's a branch of something. I don't know, but that grain's going in all kinds of different directions. So it's gonna be kind of weird to see, or it's gonna be finishing. It's gonna be fun, right? Trying to sand and finish that weave pattern and all. So I'm hoping that's why I'm thinking the 16th inch ball nose might be the way to go. So it's like pretty much detail finish when it's done. But a project like this and everything, if I were running my normal machining runtime, which is around $30 an hour, we're at just for the runtime, we're at $300. So, would that if it turn, and that's not counting if I hollow it out, finish it, none of that. That's just the carving of it. And would it be worth $300 when it's all said and done? I've seen things, carve for crazy or sell for crazy amounts and all. And I'm usually conservative with my pricing and all. So I can't I'm not a guy. I'm not the guy to ask, hey, how much should I price this for? How much should I price that for? Because I'm low on my prices. Um, but at the same time, who knows? It might be something unique enough to where, yeah, it is. You know, um, it could be a cool little cookie jar or something. All right. Well, listen, everybody. We are at 9:46. We're at 2 hours and 33 minutes. We are going to sign off at this point, unless anybody has any questions. Let's see here. Bruce did. Now, hold on a second here. Um, there were a couple of comments that I wanted to throw out here. Michael Bell says, add tenons on the top and bottom with a paper joint for use on the lathe. Yep. Yep. Add tenons and all. So basically, to do that, um, what he's saying is a paper joint basically is gluing on little tenons on the end with paper in the middle, so they kind of pop off easy and things like that. So that's pretty cool. 3D carving on the lid to my uh, blanket chest is about 1 hour to rough and 12 hours to finish on with a 1/16 inch ball nose. Yeah, Bruce, that's exactly where it gets into some long run times. I did a carving for a the governor, sorry, the mayor of Ocala ordered um, a cabinet to be presented to the mayor of Kentucky at the Kentucky Derby. And that cabinet had 3D carvings on the doors, raised panel doors. It had carvings all on the sides, and it had the Ocala seal on it. It had There it was filled with bottles of our Marion County's finest bourbon, and it was just a really ornate cabinet. All the 3D carving on all the way around this thing, and all the parts. It was a 140-hour runtime. Uh, so on that one cabinet, and all the detail and everything, and you know, just straight run. Let it cool down every once in a while, let it run. But yeah, that was the longest one that I've ever ran. 140-hour runtime for that project. Let's see here. That is a labor of love. Crystal thinks it's worth $300. There you go. Part of Aspire clip art package. Thanks, Laney. Thanks, Laney. Great show. Thanks. Yeah, man. Dave, you're just getting into that fourth axis, Dave Gatton. So, for sure, man. Hopefully you like this one. Just something, fun to see. And Dave, you were kind of looking at Aspire, as a possibility or something, but maybe this kind of, I don't know. Maybe I did something to a little bit of inspiration there. Um, all right. Well, you guys and girls, if you like this video, give me a thumbs up on the video. It really helps the channel. If you're not subscribed to Spindle TV, be sure to subscribe. And if you're watching any of these videos and you go over to Facebook and you go to join the digital or the I say digital car, the Spindle TV subscribers group, right? One question I ask on that to be able to join the group is, are you subscribed to Spindle TV? Now, a lot of you have been honest and said no. And I think, what? But yeah, the only way I'm going to let you in the group is if you're subscribed. So be sure to hit that subscribe button, hit those bell notifications, for videos and all that come out. But that way you can join the group and chat with everybody, all the friends that you make during these live classes. You can continue on, share your projects, your inspiration, ideas, ask questions, get answers in the Spindle TV group on Facebook, Spindle TV subscribers group. Check it out. Spindle Training Videos is our main Facebook page, and you can get to the group from there. But yeah, be subscribed to Spindle TV in order to join the group. All right. Until next time, everybody. I'll see you soon. Thursday, 7 o'clock, same time, same channel, 7:15. We'll be live in the shop, bringing this project to life. Thank you all for joining me for those in the shop videos. Just trying to fill them out, see how they're doing. They might not, they might not pan out and they might not last long. They might keep going, but get more refined and all. But thanks for joining me for those. So be sure to do that Thursday night, 7:15, same time, same channel. And y'all have a wonderful evening. Hopefully you pick something up out of this, and it'll get you into making something round. See ya. Good night, Dave Gatton. Good night, Troy. Good night, Vern. Good night, Crystal. Good night, Dean. Good night, all of you. Dave Garmo, Vern, Ronnie, everybody. I appreciate all of you. I didn't name everybody, but that's who I just saw right in front of my screen right here. But I appreciate you all. See ya. And the reason why I'm keep talking is I'm waiting for this thing to end broadcast. Oh, that's because I didn't click the button. Hold on. See ya. Oh, again, there's two buttons.